So, welcome to this session. My name is Nirmal, and this session is titled Digitalisation is Leading to Operational AI. I'll get into defining these terms in a minute. Just wanted to start off with a bit of an introduction. I have a couple of decades of building practices experience in analytics. I've co-founded a couple of analytics companies and have consulted across different verticals. Uh, I sold my stake in Fractal Analytics, which was my first company, and my second company got acquired. Post that, I've been an independent consultant, and the last few years have been working at NUS-ISS on data analytics, and I teach data analytics courses. I also do a research, and I like interacting with the industry. So that's a bit about me. So let's begin with a little bit of an introduction as to what exactly are we talking about when we're talking about AI. When we're talking about AI, we're talking about three different things coming together. You have statistical algorithms, you have business acumen, and that needs to be wrapped up in some kind of software and implemented in some kind of automated process. So if you put all of these three together, that's when you're getting into automating or solving real world problems. And that real world problem is what is being uh, being done in an automated fashion using artificial intelligence. Analytics is at the backbone of this. So analytics is another keyword that keeps coming up once in a while, and let's try and understand what is this analytics and what is
at that
this
level.
AI doing to us.
So I think for login
So
with SingPass, I think
one
everyone is
way to
familiar.
look at
It's not
this
new, but I think what
is
we've done under NDI is to make it
by way of
passwordless.
cartoons. So here's a cartoon that I found very interesting. So you look at data and move on to information. You start looking at some kind of things that are happening within data and connect them with dots, connect the dots into knowledge. You start getting some insights and wisdom, but you should be careful not to look at getting caught in conspiracy theories. Now, let's look at analytics and let's try and understand what exactly are the common goals of analytics. So this is a good slide that has invented some terminology. This terminology came up with Gartner. It's been terminology that has become industry jargon for the last 10 odd years. So at the beginning, you start looking at descriptive analytics. Descriptive analytics in some sense is baby analytics. When you're talking about what happened, when you're talking about what happened in the past and trying to describe that, it is similar to organizing data with respect to some purpose. If you have books in your library, you would organize those books in the library in certain patterns. You'll probably organize them, let's say, by author. You'll probably organize them by size. Sometimes you'll probably organize them by alphabetical order. And I've heard of people organizing them by color just to look at the aesthetic sense of it going well. Now, each of these organizations is different. And the reason why you do these different kinds of organizations is to achieve a certain goal, achieve a certain objective. So, similarly, if you're looking at organizing data, if you look at, let's say, the MRT data and see where have trains got delayed, what happened, which particular trains got delayed. Okay, trains got delayed in the northeast line, trains got delayed every weekend, and trains got delayed whenever there were multiple trains on the tracks. So that kind of gives you a sense of what happened and when did that happen. Now, from there, you start moving on to diagnostic analytics, and the link is this: when did it happen will lead to asking the question, why did it happen? You try to connect the dots. You try to say, okay, so every time there is one train that came in, there was, you must have heard the rogue train situation or the case study that happened a few years ago. There was one particular rogue train, and that rogue train, whenever it came across, it led to disruptions in the other trains. So, what caused another particular incident? Sales went down in a particular geography, and the organization starts looking at why did that sales go down. Sales went down because this particular geography, northern region, did not contribute too much. It went down because product A did not contribute too much. So when you start connecting the dots and answering the question why, almost like a clinician or a doctor trying to figure out what was the reason why a certain symptom occurred, then you get into the realm of diagnostic analytics. So, descriptive and diagnostic are the first two steps that you look at in analytics, and then you move on to predictive analytics. And when you're talking about predictive analytics, you're moving from the past to the future. You're using whatever you've done in descriptive and diagnostic analytics and looking at the trends of the data and predicting what is likely to happen in the future. You could predict, hey, this is the progression of the virus, and these are the kind of trends that you see going forward. There is going to be a second wave, there is going to be a third wave, and hence you can prepare for that. You can look at, hey, this is going to be the tourism that is currently predicted in this year, and of course we have to start looking at how will tourism pick up down the line and what is the prediction on that. What happens with predictive analytics is the minute we start looking at predicting towards the future and know what will happen, we get some insights that we can use, and those insights are what we can use to deliver or we can use to change our strategy. And how do you change that? How can you make that happen? That's the realm of prescriptive analytics. You kind of know the foresight, you know what is going to happen, and hence you optimize everything. So you optimize things so that you can fine tune every single element and make sure that you get the best out of that particular insight. So these are, in some sense, progressions of analytics, different kinds of analytics. And in most projects you would be going along this journey. You start off with descriptive and go all the way to prescriptive analytics. Now that we have a sense of what kind of analytics happens in different places, let's look at some examples across a few industries. So I'd like to pick a few. First, I'd like to pick banking. Banking has historically been the first off the blocks. Banking has historically been always using analytics, and I'd like to talk about two examples. One can talk about multiple examples. If you talk about analytics within banking, you can think of thousands of different use cases. Let me pick two. So, credit decisioning is the first I want to talk about. When you're talking about credit decisioning, the example is about how you look at giving credit, the process of giving credit. When you give credit in, say, a situation like a credit card or a home loan or a personal loan, you're giving credit to somebody, and the person who takes the credit might default, might not return the money back in time. In which case, you not only lose the interest, you also lose the principal. That's a big, big risk. So what you want to do is you want to be able to give credit to only safe customers. You want to be able to give credit to customers who are not likely to default. So the way that is done is you build what is called a credit score. You try and give a credit score to different individuals. Usually is a number between 0 to 1,000, and that credit score is what will determine how risky that particular individual is. And basis that, you take credit decisioning, uh, credit decisions. So that's one example on banking. Let's take another one: anti-money laundering. Money laundering is today becoming a significantly important thing to watch out for. What is money laundering? Money laundering is when you've got illicit gained money, let's say money of a drug dealing operation, or money that is connected with terrorism finance, or money that is being siphoned off because of corruption. So these kind of situations, money is laundered, and the idea is to convert money that is illegal money to legitimate or clean looking money. So that washing process is the term laundering used for. So this happens very in sophisticated manners. So there are criminals who look at layering the money. They layer it through multiple different companies. There are companies which have subsidiaries, which have uh, uh, different kinds of power of attorneys given to different individuals who have directorship on different boards, and that kind of complex structure is one way of hiding money. The other way of hiding money is to send money through a circuitous route. You send money over invoice or under invoice, and that whole cycle is something that ends up transferring value from party A to party B. Now, if you have to figure out or prevent this money laundering, then you need to be able to find out the patterns, and you need to be able to figure out what kind of money laundering is happening within the system. And Singapore, especially given the fact that we are a financial hub across at least this part of the world for sure, we need to be very, very aware of that. The recent scandal that happened in Malaysia was has woken us up, and for the very first time, we have actually seen a punitive action taken in Singapore. There have been bankers who've been arrested in Singapore for money laundering. Uh, so that's one place where there's a lot of statistics, a lot of analytics that's going in. Let's talk about healthcare. Healthcare is the oldest. So healthcare has always been uh, even before banking, started off working on analysis, started off working on what was not called analytics then. Clinical trials, for example, has been happening for quite some time. The vaccine that has been rolled out has undergone clinical trials, and when you're looking at clinical trials, you're looking at statistical ways of testing out whether a particular drug is effective or not. You divide the entire testing population into a control group and a test group, and you have one particular group getting the drug and one particular group getting a placebo, and you check whether the drug actually has statistically significant efficacy compared to the control group. So that kind of statistical tests have to be rigorously done in healthcare. Drug discovery is an interesting phenomenon that's happening recently. A recent antibiotic was discovered using purely machine learning techniques. In MIT, they actually looked at the chemical properties of different compounds, different molecules, and analyzing all of those properties, they figured out some particular molecules are perfect candidates for killing bacteria, and an antibiotic was discovered. So that's pretty interesting. So mathematics has started getting into healthcare, and that's a very, very interesting trend. Let's talk about government. What is happening in the government? Smart city management is happening in a big way. So what is smart city? Put the word smart in front of anything, it becomes smart. That's becoming almost kind of an interesting jargon. The secret of smart city is IoT, where you're talking about Internet of Things, where you're talking about small devices which are connected to the internet. There are 50 such devices per person on the planet today. So one way to look at this is, there are these flex sensors, for example, this thick, this long, costs about $1 in Shenzhen, China. So you have these flex sensors which give out electricity, give out tiny amounts of electricity on the basis of the amount of bend that happens within the flex sensor. So you put these flex sensors in a chair, and then you can actually figure out whether there's somebody who's sitting in the chair or not. And you put enough such sensors in a room, then you can actually figure out very simply, you can rig together a system where you can find out the occupancy rate of the room. And now, if you know the occupancy rate of the room, you can connect that to the air conditioning, and that helps you regulate the air conditioning. So your air conditioning has become smart. So that's a smart utility. Extend that to a building, you can have a smart building which has all the utilities working in taking in data and working in synchronous fashions. We have sensors all over the place across the island. So we have sensors on the roads which look at traffic situations and tell us what is likely to be the travel distance, travel time between a point A and point B. So there is a lot of data that's collected across the island, and when you're talking about smart city management, all of this data starts growing up. There is a lot of such data. So if you're talking about machine to machine interactions, just because of the sheer volume of such interaction, volume of such data, you necessarily have to deal with big data, and you have to deal with real time fast data. So that's one thing that governments have to deal with. The second one that governments need to deal with is common data infrastructure. If you can provide data infrastructure and give that data to public, give that data to people who can work on it, then sharing that data can only help in doing wonders. I want to talk about a couple of examples here. One is there was an earthquake in Haiti in the early 2000s, the country Haiti. So this earthquake in Haiti, rescue efforts in this during this earthquake were hampered, and the rescue efforts were hampered because there was not much of good maps of the region. So you didn't really know whether which particular region, which particular area was a hospital, where was a street, and so on. So they actually got public to volunteer. So they created Wikipedia style. They created an entire map online, and people contributed, and people started marking out from the photographs, hey, this is a road, this is a hospital, this is a particular area, I know the label of it, and so on. And that kind of labeling made the Haiti map the highest resolution map in the world today. So that's an interesting thing. So what has happened here is that you've actually, with very little money, invited people and got people to work on data just because you've created a common data infrastructure. So one way to think about this is that governments need to start providing data and giving data out to public so that they can start using that data and do interesting things. Let me talk about another example. NASA today has discovered quite a number of exoplanets. What's an exoplanet? An exoplanet is a planet that revolves around a star that is not our sun. So we have 8 planets, and almost every star apparently has planets. And they found a few thousands of them. How do you find these exoplanets? You find one of the methods of finding exoplanets is through a method called transit. So you use a telescope to look at a star, and whenever within the field of view there is a planet that travels between the star and you, and that transit of that planet actually leads to a dip in the light of the star. Studying the pattern of that dip will give you a lot of parameters of that particular planet, like atmosphere, chemical composition, and so on. So the latest set of planets have started being discovered by citizen astronomers. NASA cannot handle the entire sky and cannot look at observing the entire sky. That's a huge amount of data. They've actually given a lot of that to public, and citizen astronomers have started looking at those those data points and identifying which particular stars are candidates for newer uh, planetary systems. So again, what is happening is that giving data out, sharing data out, is helping create newer solutions. Let's talk about new age. New age, I want to talk about a couple of things. The first thing is that visioning algorithms have started coming in and becoming mainstay. So today you can actually look at a computer and using the images from the camera, you can detect things, you can read text, you can, for example, see your face can be detected by a phone. And that kind of visioning algorithm means that today a new data entry mode has started. The new mode of data entry essentially is your camera. So you can use your camera to capture documents and use OCR to get data out of it, or you can capture traffic within a particular building. So there's data that can be captured using these cameras, and that's an interesting development. The last point I want to make here on these examples is behavioral nudging. So when you're talking about behavioral nudging, how do you nudge someone? How do you do a small little nudge which helps change behavior? An example I want to talk about is one particular highway in India. There's a 6-lane highway between Bombay and Pune, and that particular highway has a minimum speed limit, not a maximum speed limit. Because it's got a minimum speed limit, people go very fast on that highway. Obviously, if people go fast on that highway, there are likely to be accidents. So given those accidents that were happening, there was one firm which was tasked to reduce those accidents, and they came up with an innovative solution. The solution went this way. So if you look at the highway has broken white lines in the center. So they changed the width of those broken white lines. So if you had a highway and near the accident zone, they had these broken white lines close to each other. So you had broken white line, broken white line, broken white line, and then broken white line close to each other, and then broken white line spaced out. Now think of the driver who's driving past. If the driver is driving past and seeing these white lines go by, when the driver comes to the accident zone, the white lines, because they're spaced closer to each other, they appear to be going super fast. And that creates an illusion in the mind that the car is speeding, and automatically the driver applies a brake. Genius of a solution. How much money did they spend? Probably with the paint, they even saved money. But the point here is that if you have to implement something within analytics, you also need to look at behavioral psychology. You need to understand how human beings think and use that to your advantage. So that is the realm of behavioral nudging. Now, what is happening with AI, automation, and robotics, which is going pervasive across different industries, is that there is a fear that robots will replace jobs. Yes, they'll replace automatic, mundane jobs and also some intelligence as well. And current skills will become obsolete. This is happening across the world. That is for sure. But there is some good news as well. There will be new categories of jobs that will emerge. Somebody has to develop those AI systems. Somebody's got to supervise those systems. Your entire way of doing business, your entire way of working on different processes changes. And so there's somebody who's got to figure out how, in this new world, in this new normal, how do you respond to those paradigm shifts? How did the US government respond? The US government came up with a policy which said that you need to invest in AI and develop AI for its benefits. They want to educate and train Americans for the jobs of the future. And the jobs that are being replaced, they want to aid those workers in the transition out of their redundant jobs. So governments have woken up to this fact. It's a new normal, and that's kind of happening. Now, let's look at some trends. There are some underlying trends that are leading to a new kind of artificial intelligence, and I want to specifically call that out. Let's talk about what are the trends that are happening. So we spoke about the fact that computer vision is coming in a big way. So computer vision is leading to new kind of data entry. So suddenly there is no concept of saying I don't have data. You just put in cameras, you get data, and cameras is just putting up one webcam. It's not a difficult thing to get in data. So today, not having data is not an excuse. So there is no process that is digital proof. Every process can easily be digitized. Data can easily be collected. Now, robotic process automation and digitization are two trends that are leading to simple automation of these processes. So if there is some kind of a process that involves multiple steps, if it involves standardized steps, if those steps are routine, then it can be easily automated. So data is available and processes can be automated. Now, the third thing that's happening is mobile apps have led to quick and pervasive deployment. So you can use these processes anywhere. So you're not restricted by location, and that's an interesting trend. What that means is that, like the consumer world, the operation enterprise world, or even the government public sector world, is leading towards or leaning towards something called operational intelligence, operational AI. And that operational AI is becoming very big, very important. So let's talk about a few such examples of what this operational AI is about. The classic case is citizen service chatbots. So there are chatbots that are coming in very prevalently. So with a chatbot, what you can do is you can answer frequently asked questions. So you have questions that need not wait for an answer immediately. If there's a standard answer, you can immediately answer that standard one. Or you can direct the answer to the responsible person, responsible department. So you can direct these requests to the appropriate department so that you can save a lot of time in that process. You can automatically fill up forms. You don't have to fill up these forms continuously. You don't have to repeatedly ask the same data of multiple people. So chatbots, in a sense, are taking processes and saying that, hey, let me look at a process as like a chat between people, and let's start building in the process into that story. So the business world calls it conversational commerce. So today you're not booking any flight tickets on websites. You're actually taking a Facebook like chat or a WeChat like situation wherein you chat with the airline. You say, I want to book a ticket between Shanghai to Guangzhou, and the chatbot responds with, okay, so here are the options. I have these flight options. Now you select one of the options and you say, I want to pay. Then the chat window itself comes up with, which payment method do you want to use? Do you want to use your Visa? Okay, yes. Then the entire transaction is a conversation. You can very much, without leaving the chat window, consummate the process. And it's not one process. What has happened here is there are multiple processes that are coming in together. So the multiple processes that have come in together is: one, payment; two, identifying the flights; three, picking the flight; four, booking the flight, selecting what seat you want, what kind of meal you want, and so on. So multiple different processes have come in together, and this is the new website. So websites are going to die and chat bots are going to take over, is what people are saying. So I think this is ripe for government. I think citizen service chatbots can completely transform the way you can interact with citizen services, with government organizations. Agencies can collaborate and provide single unified chatbots. So that's one thing that I see happening today. Example 2: healthcare triage is something that healthcare professionals have over a period of time perfected. So the triaging concept is that the doctor's time is very valuable. So the specialist doctor's time is even more valuable. So what you're trying to do is you're trying to do an efficient sorting of the queue in the system. Today, if you go to the A&D section of any hospital, accident and emergency section of any hospital, the first thing that happens is a triage, which is you have nurses, nurses who come in and meet you, and they take basic information. They look at, is there an emergency? What is the situation? They assess that situation. And that assessing that situation, they are equipped to figure out, hey, does this have to be immediately treated? Does it need to be immediately sent to a specialist, or can they wait? And where is the routing? So you look at patient data, predict the patient risk score in some sense, and prioritize the processing. If you have to do that, you will need the prediction of the risk score with some analytics at the back end. So the AI process that can, operational AI process that can enhance this entire healthcare triaging is very analytics dependent. So this is a trend. If you look at this triaging trend, this is a trend that is applicable across different places. It's not just healthcare. You can look at any process that has a huge volume and almost treat it like a triaging situation. Let's talk about another example. This is an example of the Durham Constabulary in the UK. In the 2017 time space, what happened was there was a lot of downsizing of the workforce that happened, and because of the downsizing, they had to figure out how to prioritize their time, and they had to deal with a lot of let's say there's an old woman who comes in, and the old woman actually has been accused of some really petty theft, a very small incident. Now, how much time are you spending looking at that old woman's history, and how much time are you spending looking at whether that old woman is a threat to society or not? I'm just dramatizing the case for just illustration purpose. But the idea is that they used something called a harm assessment risk tool. So they basically looked at the criminals who were coming in, or the people who were arrested. They looked at their risk assessment as to how likely are they to commit a repeated offense. And if they are not very likely, then there are certain ways in which you can deal with them. If they're very likely, there are certain ways in which you can deal with them. So this was used as an additional. So they didn't take the decision on the basis of this, just the HART. They actually used that in conjunction with human judgment. So this is an example. Again, if you look at it, it's got very similar trends. Like it's almost like triaging. So you've got a recently arrested person who's coming into the police station, and you're triaging the situation to see if downstream activity can be managed in a more efficient way. Let's talk about another example. So in the US, in a particular county, they used Allegheny County, they used a family screening tool. So this is a predictive risk model that was designed to improve child welfare call screening. So calls started coming in, a lot of child welfare calls, and you know the US, right? So if the parents are a little strict and say, okay, so you haven't done your homework, I'm going to call your teacher, then immediately the child picks up the phone and says, okay, I'm going to complain to child services. So it's a common thing to receive a lot of calls which don't really need in-depth attention. At the same time, if you are not careful, you might miss out the odd case or two. You might miss out a child who's really in trouble, and maybe the child is too scared to even talk. So how do you make an assessment? How do you judge that? So here is again where they used an analytics or an AI tool, where they had a predictive risk modeling tool, and this was designed to improve this whole call screening process. And again, similar to triaging. So what's happening in all of these examples is you're looking at a process which has multiple outcomes, and you're seeing, can you efficiently start looking at this process? Can you make this process far better? Can you use AI to ensure this process is done in a more effective fashion? So here's the way one could think about an operational AI blueprint. Step one, you need to identify said processes. So if you have to identify said processes, what are the kind of processes that are ripe for operational AI? These are processes with differences in outcomes, processes which have varied outcomes, processes which involve human judgment. And you need to also identify what are the benefits that you would get once you improve these processes. Once you do that identification, then you need to do the engineering. The engineering involves, not only you need to digitize the process and collect the data, so you need to take the data, but you use analytics to improve the efficiency, and then you need to implement that. But before implementing, you probably want to pilot it out before the full scale automation and rollout. So that entire engineering process involves analytics, understanding of the process, and software implementation. Now, that's not enough. You need to take a sustainable approach to it. You need to go beyond just engineering. So, one way to think about that is you need to test and learn. So, the it's not just one process that you are modifying. The minute you change that process, you will have other downstream implications. And so, you need to work on change management issues. And if you have to keep modifying that, you test a little modification and you learn from that, you try another test and you learn from that. So that's called a test and learn cycle. You also need to create human oversight on the new processes. So you can't just completely automate this and leave it to the computers. You need to have human oversights to check whether things are happening in a proper way. Governance metrics, data quality metrics, or sometimes there could be biases within the data itself. So looking at biases is very important, and an example of that is Amazon came up with an AI system to look at how do you automatically shortlist candidates, right? So they had a huge volume of incoming candidates, and they wanted to shortlist those candidates automated fashion because it was just taking up too much time for the HR resources. So what they did was they looked at all the resumes of the people working at Amazon, identified the high performers, and said, let's look at what characteristics from the resume lead to high performance. Now, there was an inbuilt bias that happened. Amazon had lesser number of women compared to men. So what happened is that the entire process was biased against women. So your shortlisting process started discriminating against women. So if anybody who played women's hockey, women's sports, then they would be getting negative points and they would have stand a lesser chance of shortlisting. So sometimes there is bias within the data, and you need to look at those biases. And the only way you can solve those biases is you don't trust the computer completely. You need to have a human in the loop. You need to have a human in the system. So you need to create that human oversight as well. Now, one point is that how do you start identifying these decisions? What are the ways in which you can identify these decisions? So here's a quick exercise that I will run you through. So this is an exercise that we do in one of our courses called data-driven decision making. So we look at different decisions and we try and put those decisions on a 2x2 matrix. We try and put those decisions on a 2x2 matrix which talks about decision taking frequency and decision impact. So if you take these four, I'll pause for a minute. So maybe try and see if you can take these four decisions: launching a new card, choice of meeting place, or automated product recommendations on net banking, or stationary supplier choice. Where would you place that on each of these four quadrants? So here's the way you'd possibly place that. So I'd possibly place them. Launching a new card is probably very high on impact, but it's something you don't take the decision very often. Stationary supplier choice is not a big deal. It's not very high on impact, and you take that choice, take that decision once in a while. Choice of meeting place, again, is not a big impact decision, but you do it every time. So automated product recommendations, let me change that to product course recommendations on Skills Future portal, for example, instead of net banking. So if you have, let's say, a Skills Future portal and you want to be able to automatically recommend some new course to that particular citizen, then that's something that a decision you want to take very, very often, and it has a very high impact. So obviously, needless to say, the the top right hand corner is where you get the maximum impact. And hence, those are the decisions, those are the processes that you want to lead towards operational AI. Those are the ones that you want to make sure that you ultimately try and automate. And so there is some kind of a prioritization tool that this will help you with. So sometimes it's not about taking those decisions, it's about articulating that in a good way, it's about articulating the story in a good way. And so it's not always automating that entire end-to-end software, but looking at the trends and trying to figure out what is happening in the trends. So let me stop this and share another screen. I want to share a screen here which shows you a good story. So this is an example of a good story that can be told using data. So this is data. On the screen you should be seeing bubbles or circles. Each of these circles is a country, and the size of the bubble is the population. The color of the bubble is the continent. So the two red bubbles are the Asian giants, India and China. X-axis is income and y-axis is life expectancy. So all of these blue countries are all Africa, which is like really bad in terms of life expectancy and income, and way up here is United States. And okay, so here's an interesting country that we might be aware of, which is doing very well in terms of life expectancy and income. Now, if I was to animate this across time, you can start looking at different trends that have happened right from 1800s all the way to if you look at around this time, the European countries, the yellows and US were away from the pack. Industrial revolution was what gave them that edge. This was the dawn of the 20th century. That was the Spanish flu, world wars. Now, around this time was when China started doing very well in terms of life expectancy first, and then started doing good on income. This is the time India liberalized and India started following suit. I can tell you 200 stories with just this chart. So the point here is that good storytelling sometimes can uncover trends. And if you were to look at operationalizing your processes, you want to be able to visualize those processes and the impact of that in a scientific, in a special way, in a data storytelling way. Now let me come back to the slides that we had. So I want to talk about some courses that you could look at. Here's a plugin from ISS. So if you want to start off on operational intelligence, maybe these are two courses that you might want to look at. Data-driven decision making and data storytelling. It's a 1-day format and a 3-day format. So when we're talking about data-driven decision making, we're looking at understanding the use of data and how do you look at different life cycles of the entire process, different techniques, and we also look at organizational maturity. So it's a course that data-driven decision making is a course usually uh, for individuals who want to get the breadth of analytics, want to understand what is going on in operational AI and just get their feet wet. Data storytelling is where you want to start appreciating data visualization. You'll do exploratory, explanatory, and diagnostic analysis. You look at dashboards and infographics as two mechanisms. So data storytelling is again light on technology. So these are two good entry points that usually we suggest for our participants to start off with. So that's really what I have in terms of content, in terms of slides. What I want to do is I want to pause here and I'll take questions. So please feel free to send in your questions, and I'm here to respond to them. Yeah, questions, please. Yeah, I'll give you a couple of minutes to type in your questions. Awesome. So there are questions coming in. So okay, so I have a question which is actually it's a very good question. What are usually the stumbling blocks you've seen in operationalizing AI? Mm, I think the first stumbling block is, are you asking the right question? Are you identifying the problem really? So a lot of times analytics jumps into data and they start saying, okay, so here's data, let's start getting into operationalizing uh, some analytic solution on top of that. So identifying the business question, looking at what is it you're trying to optimize, how will that benefit be driven, what is the success metric, spending a lot of time getting the scope properly are uh, are the important things that you need to do. So that's the first thing. So one stumbling block is inadequate understanding of the process, inadequate domain understanding. Data tends to be the second stumbling block. So usually it was earlier lack of data, but today there's data everywhere. So now the problem is not lack of data. The problem, funnily enough, is actually too much data. So you have so much data that it is almost difficult to identify A, what is relevant, and B, how do you connect all of that. So a lot of data cleaning, data integration, putting that together into one place. So processing that data becomes a challenge. So much so that it actually would occupy the majority of the time in an analytics project. 80% of the time is in data cleaning and data processing. And the third stumbling block is inadequate focus on implementation. So a lot of thinking does not look at how would you implement this and what's the way in which the implementation can be fine tuned. And that implementation is something that, to go back to the first point I said, you want to start thinking about implementation when you're framing the problem, when you're designing the problem. It's almost like design backwards, design with the implementation in mind, and then start working towards that. So to summarize, I see three stumbling blocks. One, inadequate identification of exactly articulation of the problem. Two, data processing. And three, implementation. The next question I have is, where are these courses you just mentioned? And question three, are those courses mentioned in the ISS portal? Yes, if you go to the NUS website, ISS website, you will have a chance to look at all the courses that are available at and I'm sure my colleagues uh, will give you more pointers towards where else you can see these courses on. I have another question. Any example that we can use AI to prompt behavioral nudging? Yes, I can give you a couple of examples. Uh, so one example that's sync power synctel the our SP Power, right? So we look at a utilities company which has national benchmarks. We have national benchmarks in terms of people who are above average in terms of looking at their electricity consumption or their water consumption. That's a behavioral nudge. We're not saying you're wasting water. We're saying you are above average compared to your cohort. So that's one form of a nudge. I'll give you another example. The UK government actually created a unit, and the unit was called Behavioral Nudge Unit. So this unit would study data and come up with behavioral nudges that would help in social outcomes. One task they were given with was to look at juvenile delinquents. So young people who had committed offenses before they are adults. So these juveniles, they were trying to look at how do you encourage them to go to school. So there was a lot of juvenile school dropout. So a behavioral nudge that they came up with was they actually sent an SMS to that particular student's friend. So student's friend would receive an SMS saying, Jack came to school today or Jack did not come to school today. Just a reporting, no complaint, nothing of that kind. Just said, Jack came to school today or Jack did not come to school today. This small nudge over a period of time, in the 3 months I think it was tested out, trialed out, saw a 38% increase in attendance. So you can have these kind of small nudges go a long way. Hopefully that should give you a sense of behavioral nudging. Okay, how different is operational AI from the current predictive modeling? What are insights that can be substantially gained? Okay, so if you look at the examples that I spoke about, all the four examples that I spoke about have predictive modeling as an element inside. So if I was to look at operational AI is in some sense a superset, and it involves predictive modeling inside. Of course, predictive modeling can also be done in non-operational AI. That's a different matter, but let's talk about just the operational UI use case. When you're talking about operational AI, you're basically talking about the operations or the process of a particular organization, and can you improve that in some way? And you could use predictive analytics to do that. But after you gain the insights, after you get the fact that these kind of people prefer these kind of outcomes, you also need to do the implementation part. You need to embed that into a process and ensure that the implementation is done. Only when you do an entire end-to-end implementation would you be successful. So they're very joined at the hip, they're very connected, and predictive analytics is one sub part of it. Okay, the next question is, how do we reduce the effort in cleaning data in order for the data set to be useful? Fantastic question. Of course, you must have heard the term garbage in, garbage out, right? So you have dirty data, you will have dirty output. And so the and it's a big problem because you don't even know that your output is bad. So that's like, not only are you wrong, you don't even know you're wrong, which is like the worst situation to be in. So how do you deal with that? There are very specific scientific ways of looking at data cleaning techniques. So there are things like, how do you look at missing values? How do you impute those missing values? How do you look at data quality? So data science deals with data cleaning and transformation in a scientific way. So you have specific skill sets that you can learn and do that in an ongoing basis. So the effort can be reduced if you can automate those and create generic scripts. The good data scientists do that. They create generic scripts that can automate the process of and generalize the process of data cleaning. The next question: how do we solve the problem of data residing in different departments silos? So data residing in different departments and silos is a very common problem in large organizations. And the way to sort that out is to start from the top. There has to be a top-down approach to it. It has to be top management, senior folks, the CEO or the heads of the organization need to start and roll that down. You have to start bringing that top-down approach. There is no other way around it, because you don't have junior folk incentivized to go beyond their organizational boundaries. And the way to think about it is, the more you share data, the better it's going to be. So you've got to start when Singapore's talking about data being a national asset, then your department does not own that data. The entire nation owns that data. So you need to start looking at it that way. What approach do you recommend when the business users don't know what they don't know? Should the operational of data analytics and AI and understand what is relevant for the user from the business side or the technical side? Okay, so this is a very interesting question. A lot of times business users really don't know what they don't know, and that's a very, very common situation. So when that happens, what you need to do is, you should not be in a hurry to articulate this as a predictive analytics problem or a prescriptive analytics problem. You need to first discover what the issues are. You need to discover and dig deeper. So the analysis that you're doing is not to identify the solution to the problem, but to identify the problem itself. And that kind of identification of the problem discovery can be done with good visualization. So the one word answer to your question is good visualization. That was 2 words. Okay, what approach? We've answered that. Okay, there is a sub question: should the operationalization of data analytics and AI be driven from the business side or the technical side? It has to be driven from the business side. It's always business which works on it. Technical side is just the implementation of it. There is no other way to do it. Do you know, if you can, and so how is AI to workplace or worksite safety? So I don't know specific examples of worksite safety, but I'm sure there are quite a number of them. And so you can start looking at processes in terms of how do you. So there's enough and more data that's available on a mobile. So I would look at a mobile as a definite way of looking at it. And I'm sure there are quite a number of such processes that are there. It's just a Google away. Offhand, I don't recall any. So yep. So that's okay. So I'll take this last question and then I'll close. How to prevent data manipulation by certain organizations with the objective to skew consumer behavior, and how to detect this data? Yes, there are willful manipulations of data that happen. So the way to look at that is, typically whenever you collect data, you to solve these, you always have redundancies, you always have checks and balances. So sometimes you ask for the same data in two different formats, and it's very difficult to fudge or difficult to manipulate both, and so you can get caught. So there are ways to catch these people, and there are ways to look at it. For sophisticated criminals, the way to sophisticated data manipulators, the way to look at it is benchmarks and trends over time. You start looking at deviations from those benchmarks, and that can be worked. Yeah, so that clears all the questions so far, and we have 1 more minute to go, so I'll end here. Thank you very much for the questions. Hope you picked up something, and hope to see some of you at some of the courses. Thank you.